Hello, my name's Paul. I wanted to show you a quick demo of what Optane can do for you in terms of video rendering. So on this machine, I have Davinci Resolve I'm actually running. Uh, this is actually a Hades Canyon Nook, so it's an i7 8800 series processor. And I have a few drives. I have a 760p client drive and an Optane drive on here. And I have a few videos in here. I have a couple of 4K resolution videos, 120 frames per second, and you can see this is on my C drive, which is my NVMe 760p drive. So they range from 50 gig to 260 gig, and I have the exact same files on my Optane drive. I just put an OPT in front so I know exactly which drive they're coming off of. So if I open up DaVinci Resolve, I can go find those on my C drive. Here we go. I'm going to add them into my media pool. Add those three files into a new timeline in DaVinci, and I'll create it. And if I go look at the timeline now, I can see all three videos are in here. And if I scroll all the way to the end to see how long this video is, I can see it's still going, still going. Should be about, yep, 4 minutes and 26 seconds long in total. I put all three right after each other. What I'm going to do here is output this as a DPX file. So I'll put that back to my C drive. So I'm taking the videos off of C and outputting them back to C. As a DPX. DPX is basically, it's chopping up these videos into individual frames, so then I might color them or edit them individually later. And I'm going back to C. I'll add that to my render queue. I had done this previously, so yes, I'll replace anything that's in there. And I'll start my render. And you can see it's giving me an estimated time, and it's starting to go through it. So while it's going through, I'll pop up my performance monitor and just give you an idea of what's going on in the system. And first, we'll look at our C drive. Nothing's going on our Optane drive, of course. And just here on basic performance monitor, we can see my queue depth or queue length in Windows is somewhere between 0 and 10. So it's a relatively small queue depth operation, even though we're hammering this with this program, reading and writing from those files. It's a queue depth of about 6. My disk is fairly active up here. You know, it's fairly maxed out on the top graph. And if I go to my CPU is running pretty well. It's at like 80%, right? I'm close to the top of that graph on the top right graph. So I'll let this cook for a little while, and we can see I have about 2 minutes and a half left. I'll pause this for a second and time lapse. Okay, so now we're back and it completed. And you can see the time up here. It completed on the top right here, 3 minutes and 49 seconds. So it fully finished that. And I can see my CPU dropped back off, and it was, 75, 80% that whole time, if I look at that. And my disk was fairly maxed out. If I look at the top graph, and my queue depth in the middle graph was probably about a 6 or so. It was somewhere between 0 and 10, which means it wasn't a super pipelined operation. This was more of a typical workload that is a queue depth of under 10. So I'm going to go back and basically do the same thing now. So I'm going to remove my timeline, and I will add my videos from my Optane drive. So here are the same three videos. They have the OPT in front, just so I remember or make sure that they're from the same thing. So I'm going to create a new top line. Boom. Okay. Just to verify that it's the same length, so I should have three videos that are 4 minutes and 26 seconds, 4 minutes 26 seconds. There we go. So we have that, and we'll do the same thing, and we'll put it back onto the same drive. So I'm going to put it on Optane, my E drive output. Same thing, everything's the same, add to it. I'm going to replace any files that I have, and I'll start this render. So, does the same thing, except now I'm doing it on the Optane. So we'll go over to the performance monitor while this is starting up, and we'll give it a second to warm up. But what we can see here first is my CPU is absolutely maxed out. This is an 8800 CPU, so if I had a newer, it's obvious immediately when my CPU is 100% that my CPU is my bottleneck at this point. If I had a faster CPU, I would be able to do a little bit better performance. But here you can see it's maxed out at 100. And my disk, on the other hand, would go back, and here we would look at my top graph, and we see my disk is fairly used, and the bottom graph is my queue depth. So my queue depth is actually fairly low again. My queue depth is somewhere on the bottom graph about, I don't know, a 3, it almost looks like on the Optane. Let's go back. I'm back once more so it refreshes. Okay, so here, everything's refreshed. If I look at my disk activity, the top graph is not 100%. It's maybe 60, 70%, let's say. 60 to 70% disk activity. My queue depth is down here on the bottom graph. It's about a 3 or so. And my CPU is maxed out. Totally green, top graph. So what is that telling us? With the Optane drive, now we shift the paradigm where with the pure NVMe drive, the 760p, the CPU was about 70% utilized, and my disk was almost 100% utilized. Now we move to the Optane drive with this low queue depth workload, and now the CPU is 100% maxed out, and my disk drive for Optane, well, always takes a second for these things to refresh. My disk drive is at about 60% utilization. So we switch from being disk bottlenecked to now CPU bottlenecked. I'm going to pause here for a second and let this job complete. Okay, and now we're done. And we can verify that over here, and we can see the CPU. CPU dropped off. Right, we're done. So we shaved over a minute off of this time to render this 4.5-minute video. The longer the video, the more time you would save. But it changed the bottleneck. If I had a faster CPU, I would be able to do this faster on my Optane drive. Thank you for watching.